Dave and I have been collecting data for the past, basically since 2000, on highway work zones. And this presentation is going to be a combination of the things that we've learned while we've been out on site. This actually, anybody know what this bridge is? This is one of our famous bridges down in West Virginia, because we're from Morgantown, West Virginia. This is the New River Gorge Bridge. And once a year, we have a whole bunch of crazy people that jump off this bridge. And if you're into whitewater rafting, they raft the river below it. We're going to cover a brief background on injury hazards and what's going on, what OSHA frequently cites for, sorry, I need to be louder, road construction, how to work safely around trucks and equipment, and road and bridge construction hazards in general. We briefly explained who NIOSH and OSHA are. Basically, we were created under the same act. OSHA is under the Department of Labor. We're under Department of Health and Human Services. We're also under CDC. So we're sending groups of people down to the oil cleanup. We're looking at worker exposures to the dispersion agents down there right now. So we look at all kinds of worker safety and health issues and trying to figure out how to mitigate them. We're specifically charged with conducting research and making recommendations for preventing worker injuries and illnesses. In NIOSH, we have several different programs. We have a large NORA program that we're working on. It's the National Occupational Research Agenda, and one part of that is a construction program. And our construction program is kind of like a three-legged stool. We have intramural research, which is research that we conduct. It's a small portion of it. We have a National Construction Center research, which is CPWR, and then we have extramural grants that are funded that are done through college and universities. So we have three different things that we try and focus our research on. And recently our construction program was reviewed by national academies. We did very well. We have 8 programs at NIOSH, and we scored pretty much in the top of the 8 of them. We scored 5 out of 5 for relevance and 4 out of 5 for impact, so that's pretty good. The project that Dave and I have been working on has been an intervention evaluation project called Evaluating Roadway Work Zone Interventions. We had 2 interventions that we evaluated out on site. One of them was called Internal Traffic Control Plans, which I have some information here on, and the other one was called Proximity Warning Systems. We conducted our research throughout the whole United States, mainly on the East Coast, but we did venture out to the West Coast. We went out to Idaho and California and Oklahoma, and there's an amazing difference between how each state runs their road construction and how operations are done. Depending on the distances that material has to travel, they use different kinds of trucks that impose different kinds of hazards, and they have their own unique challenges for getting in and out of sites. And we could not have conducted any of this research without the help of our states, the construction companies, our engineering, the labor unions, construction trade associations, equipment manufacturers, FHWA, and OSHA. And this is a list of our partnerships, and we've had some alliances that we've created during it with OSHA and NAPA. We actually have a neat alliance product that we've created actually available at the Work Zone Clearinghouse booth. And they have a blind area diagram that took one of our contract proposals and actually made a nice little poster available for you guys to put on site. We also aren't afraid to steal information from other people's presentations, so this is recognizing some of the people that we stole information from that had really good presentations. And as a government employee, I don't represent NIOSH, so please don't hold what I say in regards to what NIOSH believes. And any mention of any products or photos of anything aren't endorsing that product. So some basic road and bridge construction facts. We have a road system that covers 1.1 trillion miles for urban, about 3 trillion miles for rural, totaling about 4 trillion miles. Of that, we have 153,000 urban bridges, almost 450 rural, totaling about 600,000 bridges. So we have quite a few bridges in the United States. And for our road system, 65% of our road system is paved. And most of our bridges are in good repair. About 75% of them are good repair, and 12% are deficient, and 13 are obsolete, not driven on anymore. We put together a little funding slide just to see how much is being spent by different kinds of agencies. I do want to caveat that it says state spending, but a lot of the state spending is federal dollars. So how this is split up is actually who's spending the money, whether it's local communities spending the money or if it's state federal dollars spent. So the blue represents state roads that are being worked on. The gray represents the local roads being worked on. So 61% of it's state construction work being done, and the 2% is like on national park lands and stuff. Oh, I'm going to go back. I want to note that this is we have 140 billion starting for expenditures in 2003, coming up to roughly 170 billion in 2007. And then when we had the American Recovery Act, we added another 26 billion into that. So it's a little tiny chunk that went back in there. As far as work zone fatalities, we were talking earlier, Brad was talking about fatalities and how they kind of gone up. Into 2002, they got up to around almost 1,200 fatalities. And this is people traveling through and people working in work zones. It's not just exclusively workers in work zones, it's everybody traveling. So we've had an impact in our setting up our traffic control devices and whatnot to reduce the fatalities for our populations driving through the work zones. But we're still having people die at an average of 139 for highway, street, and bridge a year. So that's the number still needs to be worked on. And most of those people that are dying are being struck by vehicles and equipment. 80% of the vehicles and equipment involve construction vehicles or trucks. As far as OSHA citations, we broke it up into two different categories. We did bridge and tunnel, and we did highway, bridge, and street, and their citations are very different. Bridge and tunnel is mainly cited for falls, cranes, general duty clause, lead exposure, and working over water. Meanwhile, highway, bridge, and street is mainly cited for HAZCOM, and excavation, respiratory protection, and protective systems. So they're very, very different on what they're being cited on. Let's go into our illnesses and injuries. I did a map. The one on the left-hand side is the employment in the construction industry as a whole. The green section represents specialty trade, the yellow is construction of buildings, and then the orange is mainly us, it's heavy civil engineering construction. And the one on the right is the injuries and illnesses, and they map out pretty close. You expect the injuries and illnesses are pretty similar to the populations that are happening there. The specialty trades are broke up into four main components. At NIOSH, we look at everybody in their little silos. So I apologize for not breaking it into occupation. We look at them as what industry you work in. So the majority of the injuries are in building equipment contractors, but the rate, which is the number above it, which is based upon how large your population is, the foundation, structure, and building exterior contractors are the ones with the highest rate. They have 2.4 per 100 workers for a rate. And then we go into the heavy civil and engineering construction injuries in 2008. We don't know how many close calls there are out there. Part of our intervention project, we kind of tried to tally the relative risk of working out on site. We can't really tally how often there's a close call out there, but we can tell you how many cases there are. There are roughly 40,000 cases out there, resulting in 22,000 roughly days away from work. And of those 22,000, 1,200 of those were due to transportation incidents. If you look at our heavy civil and engineering injuries, we break that up into four groups. You have the utilities and highway, street, and bridge representing most of the injuries, and highway, street, and bridge has the highest injury rate at 1.8. Then we broke it down, highway, street, and bridge, who are being injured, the construction and extractive employees, which represents the majority of that group. The event for injuries, this slide represents the breakup of that. Contact with objects is the number one. It's at 35%, but it's not huge. It's not an overbearing. So the next one down is slip, trips, and falls, coming in at 20%, followed by exertion, and transportation incidents is down around 12. And I want you to keep that in mind for later on when we go into fatalities, because transportation really only takes up 12% of the injuries that are out there. So we're going to talk next about the fatal injuries. Well, this slide again is very similar to the previous one, with one key difference. The highway, street, and bridge, the heavy civil section, is much larger than it was in the other one. It represents a larger proportion of the fatal injuries that are occurring out there. It doesn't have that relative ratio to employment. So in this Pareto, we have, for occupational fatalities overall, we had in 2008 about 5,200. Construction fatalities were around 1,000. Highway, street, and bridge were 119. And then workers struck by vehicles in the street were 43 of those. And this slide shows the basic trend of roadway worker deaths between 92 and 2000. You can see it's a little bit of an incline. It goes from 80, 90, so in 92 up to roughly 120 in 2000. Then we had what we call a break-in series, so we had to redo our chart for the starting in 2003, where it starts at around 130 in 2003, goes up into 2005 to 160, and it's starting a little bit of a decrease into 2008. So we're seeing a little bit of an improvement there. For the fatalities, you can see by event, instead of 12% for injuries, you're talking 70% of the fatalities are in transportation incidents, followed by contact with objects and exposures to harmful substances. So if you're going to be injured, you're probably going to be hit with an object or a piece of equipment. If you're going to die in road construction, you're probably going to be involved in a transportation incident. And the major event types broken down a little further are struck by vehicle on a highway, then struck by object. And the vehicle types that are typically running into you are trucks and construction equipment, followed by automobiles, only coming in at 13%. So this says that it's really inside those barrels. It's not outside those barrels that are causing the problems for our construction workers. So we've talked about numbers. Now we're going to talk about something a little different. At NIOSH, we go out and we conduct investigations. We go into detail about what happens. We have something called a Fatality Assessment and Control Evaluations program, FACE. And we have state-based FACE, and then we have places that we actually internally go out to the sites and investigate. The ones that are in orange are our in-house ones, and the ones that are in blue are state-based FACE cases, and then the green ones are non-FACE state cases. So I'm going to go through several FACE cases and try and bring in our perspective of it all. The first FACE case is a 4-lane highway intersecting with a 2-lane roadway. And they're paving on the 2-lane roadway. So the scenario is they're paving away from the 4-lane road, and the truck has to come in. I'm going to use the mouse because I don't have a pointer. So the trucks come in, and they come down through, and they pull in front of the paver, and then they leave. And they turn around up somewhere ahead, and then they come back through to leave. So the operation, oops, I'm going too fast. The workers are over in that circle area. That's mainly where they're hanging out because they're working on that edge. They're working on the seam between the curb and gutter and the roadway. So they're finishing up that edge. Well, one of the workers decided that he was going to go somewhere else. So he walked in front of the paver and then walked down the yellow line a little bit and then turned left. And what they think was the worker was going over to the trees on the right to get out of the sun, because you're out there, it's probably 90 degrees and they're hot and they want to find some shade if there isn't a truck around. So this is the scene from the street. You can see the truck and where the workers are working. And these guys up front are probably actually doing the apron up to the main roadway in this photograph. This is the view from inside the cab, and there's a lot of clutter going on in this cab. This guy obviously doesn't have air conditioning. He has a little fan inside of his cab. There are stickers in the way. There's a bug shield in the way. And you can barely see in the bottom down here in the, let me get the arrow, right here is actually the top of a worker's head. We re-photographed it so that we can show how close this person was and how much that operator that was driving that vehicle could actually see that person who was crossing in front of him. He didn't have much hope of being able to see that person. So this is where our blind areas come into play. When we're doing trainings out on site, we bring these blind areas out because we want everyone to be aware of the blind areas of the vehicles. Most people are aware that there's a blind area to the back of the vehicle, but not everyone's aware that there's a blind area, especially on that front right side. So when you're talking to people out on site, when you're telling your workers out on site, encourage them if they're gonna walk in front of a vehicle that's going slowly or whatever, or stopped, give that vehicle quite a bit of extra space. Go, 8 or 10 feet in front of that vehicle so that you have plenty of room so that you have a chance of being seen. So, and there's another feature that comes into play. When you're out on site, and this truck driver shown up on site, he has one purpose. It's to get in, dump his load, and get the heck out of there. So his job, when he's backing that paver up, he's backing up, he's looking in his left-hand side because he's looking at his spotter who's bringing him up to the paver so he can dump his load. He's not paying any attention at all to that right-hand side. So even though he has a mirror there, doesn't mean he sees you or is paying attention to you. So don't think that that side is safe just because you can see that guy's face. He's not paying any attention to you. Out on our NIOSH website, we have about 40 different construction pieces of equipment out there that we've created blind areas for. They're available for you to download. We have blind areas available at ground level at 90 millimeters now. Roughly the height of a barrel, and then roughly height of a 5-foot person. So we have 3 different elevations for you to choose from that you can use for training. So print them out and use them as you choose. I actually have a sheet out here. If you want a printout of where the website is, you can take it and bring it back. So this is a little video that we took out when we were out on site because I talked about the person going to the trees. And we have a certain amount of human habits, and what are we going to do about our worker habits as far as, sorry, I don't think, as far as what we do, oh golly, what we expect of the workers out on site. And this shouldn't have any noise because we were making commentary. So you can see the trucks going down the way. You have 2 guys hanging out on the side of the road. They're chit-chatting. And then this other guy comes to join them, and this guy's probably texting his friend, not paying attention, or checking his loads, making sure that the trucks are delivering the right amount of material. So you see these guys are walking along. The truck's pulled up front so that it can get in line. And then there's another white truck here. Now that that other one's got out of the way, he's starting to approach. And these workers, they don't all go one way. They split. So they go 2 different directions. Now this driver has to watch 2 different groups of people as he drives through. Is this guy on the left going to stay out of the way? Is this guy on the right going to stay out of the way? So there's a certain amount of activities that that your people on site that you have to be aware of, their common activities. When they're working on asphalt, it's very, very hot. It's 200 some odd degrees. They're not going to want to stand on that asphalt. They're not going to want to stand anything close to that asphalt. They're going to find somewhere cooler to be. So where is that common place that that person's going to want to be, and how can we try and work with those natural human natures to try and prevent some of these injuries? This is another face case. This was a bridge job. This concrete delivery truck was set up to deliver the concrete there. There was a pump truck parked up on the hill there. And they had recently put in this little culvert and built up the roadway so that the trucks could deliver the concrete. And just earlier that day, they built up an extra little area so that there was enough room for them to get in there and turn around. Well, the compaction wasn't quite right, and the truck rolled over because he was In this scenario, you can see the pump truck was up on the top of the screen, and he came in where the dotted lines are. So he pulled in, turned into the little side street there, and then backed down in. And when he was backing down in, he did the natural thing. He kind of hugged the one side that he could see well. He hugged the left-hand side. Well, that was the soft side. And he proceeded to roll over the edge of the roadway. And this is basically what happens. You end up with a fully loaded truck, which is around, 45 tons if it's fully loaded, falling over off of a recently packed, it was probably packed by a dozer, not really packed by a compactor. So that's where one of our interventions comes into play, internal traffic control plans, which helps manage the flow of construction traffic in and around the site. Thank you. And it limits the amount of, it has several key principles. One of them is limiting access points, reducing the need to back up the equipment, coordinating truck equipment and movements, and establishing worker-free zones. So the key principle that we would have used here is limiting the amount that that truck has to back up. I had a couple thoughts that you could have done in order to prevent this from happening in the future. Would this truck have been able to actually come in from the north side instead of the south side? Was there some reason why they couldn't have come in from the other way to back in? If you were already going to create a spot to turn around, a spot so that it was a little wider down there, could you have actually created a turnaround spot so that the truck didn't have to back down that whole way and actually pull in and turn around towards the bottom where there wasn't as much of a risk? So that's some of the things that you think about when you're thinking about internal traffic control plans. When we evaluated the internal traffic control plans, we had several recommendations. Our first recommendation is to get everybody on site involved. And that includes the company, includes your state personnel that are out on site, and includes the trucking company and any subcontractors. And you all may think this is absolutely impossible, but it's not. Because everyone on site is interested in safety. It's just you don't always get on the same page, and you don't always talk about what everybody's safety plans are and what their needs are. We've had trucking companies come to us and say, we really hate it when the worker does this. And the construction company has no idea. They have no idea that this is causing these truck drivers that they're cursing at all the time because they've done these crazy things, that it's causing them heartburn. So this meeting brings these people to the same room and allows all those people to express what their concerns are. The second thing is inform everybody on site. Irregular personnel, if you have a safety intern that's come in just for the summer for training, random truck drivers that are just there for that day, make sure everybody on site knows what the internal traffic control plan is for the day. And then implement some things. First of all, implement parking areas. Where are you going to park extra pieces of equipment? Where are you going to park the extra pickup trucks throughout the day? If there's some changes that happen throughout the day, take a time out, let everybody know what the change is so that everybody's on board and they know where they're supposed to be. And this one's a little bit, when you're out on site, you need to be aware of how fast these people can respond, the drivers can respond if they finally see somebody. It takes roughly, to recognize that there's a hazard, takes roughly 3 seconds. And if you're backing at 10 miles an hour, in that 1 second, you're going to travel 14 feet. If you need 3 seconds to react, you're already driven over whatever it is you need to react to. So this is an example of that. There's another face case. This one's for a concrete job. And the scenario is the trucks are lined up. They're all facing the paver, which is a little different than what I'm used to seeing. And they come up to a turnaround point, and they turn around and then back up to the paver, and then they leave. So they're paving along the operation, and then all of a sudden they get up to the turnaround point, and they have a problem. They have everybody all lined up. They have, a dozen trucks piled up, and they can't turn around anymore because they're at the turnaround point. So they sent a worker out to go move everybody back and restack them. Well, as the worker's standing there, another truck comes up. So he walks over to go tell that truck, stop, I need you to wait here because we're reorganizing everything. Well, the truck that he was directing to move to another position didn't even realize that it was gone. and didn't realize he wasn't paying attention to him anymore and backed over him. So there are several things that you could do to mitigate this problem. You could actually create a separate staging area to anticipate the fact that you're going to come up to that turnaround point and you're going to have a problem in the future. You can create several turnaround points and have designated time periods that you use those. Or you can actually use one of the technologies that we evaluated, proximity warning systems. We evaluated four different technologies. One was evaluated in a different office than ours. The first one was a radar system, and you can see on the right-hand side the detection area of that radar system. It goes about 15 feet behind that piece of equipment. It alarms the driver so that they know that there's something to be aware of. And then we also evaluated radar systems that go roughly 8 feet behind the vehicle. And those ones work well for flush-mounted applications like pickup trucks. They don't work as well for dump trucks because they tend to catch the overhang of the bed because the way their band is set up. And then the third system we evaluated was a camera where they can see behind the vehicle, but it's a passive system. They have to be looking at the monitor in order to see that there's something back there. And then a system that was actually created by someone at NIOSH is a magnetic field system, where there's a magnetic generator that's on the truck, and the workers wear little tags. And when the worker gets near that magnetic field, it alarms both the truck and the worker. And it works great as long as it's a relatively controlled environment. So if there's other people, everybody on site has to have a tag, and every single truck on site has to have an alarm in order for it to work perfectly. We have some basic recommendations for the PWS. The sonar, as I said, it works best in the flush mounts scenario. It has a relatively short range, so it's better for smaller trucks. It has a decent amount of nuisance alarms. Then the radar system, that worked pretty well overall. It didn't have as many nuisance alarms as the sonar system did, and it has a nice range. And then our third system was the camera system, and the only challenge with that is it provides no alarm. So our recommendation overall is to actually combine the radar and the camera system together, and that allows the driver to hear the alarm and look and see what's going on back there, because you have a decent distance before you're actually on it.